Hi, I'm Becky, and I'm a material scientist based at Swansea University, and I work for a project called Sustain. And in this project, we're looking at ways to make the steel industry greener, cleaner, and smarter. And as part of that today, I'm going to give you an introduction to what the circular economy is, and how we can use it to help deliver a more sustainable future. So to start with, what actually is sustainability? Sustainability means that we can meet our own needs without compromising the ability of future generations to meet what their needs will be. So for humans, the earth provides us with everything we need to survive: clean air, water, and food. The earth's ability to provide these resources is declining because of how we're living. Our need for basic resources is increasing as the population of the earth increases and as people's standards of living rise. The way we're currently living is really damaging the system, and we're completely dependent on it. To live sustainably, we need to start by looking at these 4 points. We need to reduce our dependence on fossil fuels and heavy metals, reduce our dependence on synthetic chemicals found in nature, and reduce our destruction of nature and the natural habitats and environment around us. We also need to ensure that we aren't stopping people globally from meeting these basic needs. So to continue increasing our standards of living, we need to focus on something called sustainable development. So this means we develop in a way that meets our present needs and standards of living without then compromising the ability of future generations to meet their needs. Material scientists and engineers, along with every other type of scientist and engineer, has a responsibility to make sure that the work they're doing is sustainable. Engineering is one of the key influences that shapes our world, physically, digitally, socially, and economically. The inventions and innovations of engineering have created new ways of living and working, and as they have shaped our lives, they have become crucial to supporting and maintaining our quality of life. From the supply of essential services such as power and water to life support machines in hospitals, the products of engineering are threaded through people's lives, both individually and collectively. And this means that us as engineers have a responsibility, but we also have a fantastic opportunity to ensure that we have a positive influence on society. So let's talk about the different ways that we use products every day. Today's society is built on the principles of a linear economy. And here's a quick example of how this works. Products are designed for a single use. The raw materials to make this product are extracted from the earth, transported to a refinery where the basic material is made. This is then further processed to make a product. When this product is made, it's then bought by a customer who uses it. When the product breaks or is no longer needed, it's disposed of, either by going into landfill or sometimes recycled. This process is known as take, make, use, and dispose. Every stage in this process is powered by fossil fuels, which results in environmental emissions. The entire process wastes a lot of energy and precious materials, or the resources are lost when the product is thrown away at the end of its life. So what's the alternative? Here's an example of a circular economy loop. So products in a circular economy model are designed with their end of life already in mind. So it could be designed or disassembled or reused in another way when it's no longer needed for that original purpose that it was designed for. There's still some raw material extraction required in a circular economy, but more recycled material is used in this process. In a true circular economy, all the raw material would come from existing resources, but it's a step change to get us to that stage. In the production phase, some reconditioned components from old products could be used, and factories run on clean energy sources. At the distribution phase, some products may not be actually bought and purchased by customers, but instead leased out, so the company still owns the product and is responsible for its maintenance. In this way, it's in the company's best interest to keep the product functioning and working as long as possible. So when the customer no longer wants the product, it can be returned to the supplier, either to be refurbished and sold on again, or repaired and sent back and remanufactured into another useful product. Only if a product cannot be reused, repaired, or remanufactured does it then go for recycling, as actually recycling can use a lot of energy, although nowhere near as much as processing from a raw material. So what are the key differences between a linear and a circular economy model? On the left-hand side of the diagram, you can see the material flows for a linear model, and that you're constantly having to add lots and lots of resources and actually creating a large amount of waste, which is either disposed of or incinerated. On the right-hand side, you can see the material flow for the circular economy, where there's very little resources added and minimal waste produced at the end. Everything needed to maintain this model pretty much stays within the system. So in a linear economy, the main focus is volume of product production, focusing on that take, make, dispose route we talked about earlier. Whereas in the circular economy, the aim is to reduce the amount of raw material needed, to reuse products where possible, and only recycle a product where it can't be reused or remanufactured. Both models are always looking for ways to become more efficient, but in the linear economy, it's limited by the amount of energy, mostly powered by fossil fuels, that's needed to produce the volume of material and products to keep this economy going, as these products are designed for short-term use. Whereas in a circular economy, energy consumption can be significantly reduced by designing a product to have a really long lifetime with easy to replace parts in a modular fashion and considerate design for disassembly so parts can be reused on future products. In terms of reuse, many products in a linear economy are actually downcycled, so meaning the material that's involved in these products are then go on to be used in less valuable products when they're recycled. But in the circular economy, parts can be reused in the same, if not higher value applications. In this model, end-of-life products are viewed as a precious resource rather than waste to just be disposed of at the end of life. The linear model focuses on the product and selling in volume, whereas the circular model focuses on providing the product as a surface, and all the materials are considered as resources to be maintained and cared for throughout their lifetime. So here's an example of how material flows in a circular economy. So the user in the bottom there buys the product and maintains it. When they can no longer maintain it, it's collected by the company to either be fixed or reused or refurbished. If not possible, potentially go on to remanufacturing and then into the outer loop to recycling. So the tighter loop, the smaller of the loops you end up in, the less energy is wasted and the more value is extracted from the material. So in this way, the resources are kept in use for as long as possible, and we can get the maximum value possible from them. So circular economy separates growth from resource use and maximizes resource productivity by mirroring nature where nothing is wasted. So for example, think about a tree in a forest. It starts as a seed, which germinates and becomes a seedling. The tree uses resources such as light and oxygen, as well as water and nutrients from the ground. As it matures, it produces flowers and seeds and allows new trees to grow, repeating that life cycle. When the tree reaches the end of its life, its usefulness isn't over. The dead wood provides a home for insects and lots of different species of fungi. These are food sources for other mammals, and they can also use the hollows in the tree for shelter and protection. And as the tree fully decays, all the goodness and nutrients it used when it was growing are returned to the soil to support the new trees growing in the forest. Nothing at all goes to waste. So in the same way, we can recover and regenerate products and materials at the end of each service life. So by using a circular economy model, we'll reduce pollution from raw material processing, deliver savings throughout the industry in terms of time, energy, and costs, increase our resilience to economic and political shocks. So for example, COVID-19 meant there was a very sudden stop in production of goods, and this actually resulted in a lot of wasted material. So for example, in the steel industry, you can't just stop the steel making process. So steel was still being produced, but there were much fewer customers as fewer factories were manufacturing products like cars, fridges, and washing machines. So extra material was made that wasn't actually needed. We need to minimize our use of rare materials and make sure we recover the maximum amount of these where we can. These are a limited resource that will run out in the future. And by preventing them from going to landfill, we're using our resources more efficiently. There are obviously still going to be some emissions associated with each of these loops. However, they're considerably lower than those related with raw material production. And this is how you can get environmental benefits by adopting a circular economy model. In terms of how we look at waste, our primary concern in the circular economy is preventing there from being waste in the first place. If we look at end-of-life products as a resource, the last thing we want to do is dispose of them. So the most efficient material flow is to reuse, followed by refurbishment, repairing, upgrading, repurposing, and remanufacturing. Only if none of these are possible should we consider recycling and recovering the materials from a product. So what's the circular economy in a nutshell? It's an industrial economy inspired by natural systems, which heals and renews by design. It separates economic growth from consumption of natural resources, which makes sure we can use materials in a better way. We can support the circular economy by businesses shifting their function and focus to the design of more durable products, which are designed for a circular economy model, considering the use of biologically derived materials, using the appropriate business model for each product, so designing for a second life, following a hire and lease model, or incentivizing, encouraging return. We need to redefine our way of thinking and replace the idea with waste with resource. We also need to incorporate the widespread use of renewable energy as a vital way to end our reliance on fossil fuels. To design products in a circular and eco-friendly way requires early intervention when a product's being developed. Environmental impact of a product can be reduced by improving all stages in the product life cycle. But this requires collaboration and feedback at all stages in product design. So important things to consider are selecting low impact materials, either bio-derived, waste-derived, or those that are easy to reuse, reducing the amount of material used in a product, optimizing the production techniques, so reducing the energy demand and waste from each of these processes, optimization of logistics, so a sharing or collaborative economy, reduction of impact during use, so is the product energy efficient? Does it use any toxic materials? Optimization at initial life stage, so designing for upgrade or repair, and optimizing end-of-life systems, so optimize products for refurb and remanufacturing, as well as end-of-life recycling processes. How can the circular economy be applied? First, a product must be designed for disassembly. So different parts, especially separating materials, can be separated and reused in an effective way, so not downcycled. Designing products where parts can easily be replaced rather than needing a whole new machine. For example, if you just had a module of a camera or a memory chip in your computer or mobile phone you could replace, rather than having to buy a whole new piece of technology. Selecting the correct material for purpose. So for example, in a marine or sea environment, there's lots of salt in the water where some materials will have a very short lifetime, and this needs to be carefully considered. Better material separation. So sometimes precious metals like gold and silver are included in a very small amount. There are potentially so many critical raw materials that have ended up in landfill. One day we may have to actually mine landfill sites to get these materials back. For example, if you consider a car made out of Lego, if each different colored brick in the car represented a different material used, you can easily see how we could recover this material. Unfortunately, it's not that easy in real life, and some materials are actually really similar, but smart technologies are being developed that can help us separate these materials in a much better way. So here's a quick example of how Caterpillar, who make large industrial machinery, are applying circular economy to their products. So that's a great example of an area where the circular economy is being applied today. So what does make a good material for use in the circular economy model? I'm going to give a quick example of how steel could be a great material for use in this system. So at the moment in the UK, steel production accounts for around 50% of industrial carbon dioxide emissions, and that's around 8% worldwide. And that's because nearly everything is made from or made using steel. So from construction of buildings to transport, cars, trains, planes, and manufacturing. Steel is used in pretty much everything that we use every day. Steel is also one of the most recyclable materials. So if we can reduce the emissions from steel and move it towards a circular economy model, we can build a net zero society with a high standard of living. So how can we do this? In Sustain, we're looking at two big challenges facing the steelmaking industry. First, can we make it net zero? So net zero means that we can balance carbon dioxide emissions with their removal, or simply not have any carbon dioxide emissions in the first place. The ways we're looking at doing this are looking at technologies such as carbon capture as one solution. Carbon's actually a really useful element and can be used to produce fuels, fertilizers, pharmaceuticals, and even plastics. Another project we're looking at is whether we can use waste material which can't be recycled, so such as standard household waste or some non-recyclable plastics, whether these could actually be used to power steelmaking plants. Or as an alternative fuel source, whether we can find a way to produce and transport enough green hydrogen to power steelmaking plants. And the term green hydrogen means that it's produced using a renewable technology. The other part of what we're looking at is how we can make steel production and use smarter, so introducing circular economy. Can we make better use of end-of-life and recycled material? One of the current issues is that there can be lots of contamination in scrap steel, including even things such as flip-flops, but there's also other useful things in there, such as other metals like copper. If we can find a better way to sort scrap material, we could potentially upcycle scrap material rather than having to regularly downcycle it. We've already talked through some of the potential business models which could be implemented. Steelmaking is a very, very heat-intensive process, and we're looking into potential ways to use this excess energy. There are lots of processes that create heat that could actually be used for something else. So if you think about the bonnet of a car feels warm after it's been driven, but in steelmaking, this is on a much larger and much hotter scale. So how much energy can recycling actually save? So here's an example of how much we can save if we use some scrap steel. So by recycling a single steel can, you can save the same amount of energy as running one load of laundry, or watching TV for an hour, or leaving a light bulb on for 24 hours. On top of energy savings, recycling steel also saves water and reduces carbon dioxide emissions by a massive 75%. For every ton of steel that is recycled, almost a ton less carbon dioxide is produced compared to processing from raw material. So I hope I've given you an insight into the different ways of thinking about products and how we use them and how we could use them in the future. So next time you're thinking about getting a new mobile phone or games console, also have a think about the materials it's been made from and perhaps how these could be recovered at the end of its life. Thank you very much for listening, and I'll have a look in the Q&A for any questions.